Right, welcome everyone. Think we'll get started over here. And we have a lot to cover, especially celebrating our 2 years of a BrainX community anniversary that we started in 2018. And we have a very special speaker to celebrate that and to educate us about AI in healthcare, Dr. Anthony Chang. So we are very pleased and blessed to have him here. Uh, Going to refresh us and for the people who are joining for the first time, what BrainX Community is and what it is about. We started with the idea of application of machine learning in healthcare for good. Again, we're celebrating our 2 successful years. In the picture that you see over there was our first meeting, a small group that met people from all different spheres of knowledge, both medicine and engineering, which has grown to be 2,000 plus member international community now. The web pages that are available over there, and a very active group that is there on LinkedIn, sharing a lot of scientific information. And over here, we have been having our monthly BrainX Community Live sessions. And since January, ahead of the pandemic, we decided to go online because of the request coming from many. And since then, we have been located over here. Again, about BrainX Community, we have the website, brainxcommunity.com, which has 3 sections primarily: Connect, Data, and Learn. On the Connect, which is online, it has all the information about various sessions that we have had, the speakers, and some of their references or related work that is published with some photographs from the sessions. And now we have the YouTube channel. So all this is available through the recordings that are made over here and are hosted on our BrainX Community YouTube channel. On the LinkedIn, as I mentioned, a very active group sharing a lot of scientific information so that everybody can stay updated and actively participate. There is a Learn section which provides a curated list of articles. It has direct links to the article websites. They are categorized based on their medical specialty so that you can quickly go through them and find what you might need that will be helpful to you. And the data section, everybody is looking for data. The data section lists or hosts a list of various open source data sets. Again, you can just go to the links. It'll take you directly to those open source data sets. And they vary from those for ICU, such as MIMIC or the Amsterdam data set, all the way to imaging, such as the chest X-ray ones. So you can find all your data needs in one location on the BrainX Community data area. Again, with the COVID-19, it has presented unique challenges and new data sets have emerged. So there is a special collection of data sets related to COVID-19 that are all available through the data section too. Last year, we went ahead and launched the BrainX Community Europe, thanks to the efforts of Dr. Thomas Regula and many others. And we had a very successful first meeting last year, and we're continuing to expand upon that. We also created a new area called journals, where all the journals related to machine learning and healthcare, or which are primarily focused in this area, are directly available through links over there so that you can use them. And then meetings, we are all looking to get together, to learn from each other, to network and collaborate. AIMed, which has been the leader in this area, has been showcased as #1 over here. And then Dr. Chang will also talk about the very exciting new society that is getting launched soon. And hopefully everybody gets a chance to participate and join us for its first meeting too. So more about that to come soon. This platform is also to foster research collaboration. So this year, just like last year, we did a year-end review. Many members got to participate in that, and we are looking to expand this work. We are continuing to engage more of our members so that we can share more curated scientific information to everyone. And then another example of a transcontinental collaboration that we recently published in preprint right now, along with Dr. Sethi from India, looking at COVID-19 mortality determinants. Hopefully will get published in a peer-reviewed journal soon. Again, a platform that has united many. Many of these web pages and areas are there for you to use and are freely accessible and freely available to foster collaboration amongst each other. With that, I'm going to welcome Dr. Anthony Chang. He's a pediatric cardiologist and medical director of the heart failure program at CHOC Children. He's also the chairman and founder of AI Med, that is Artificial Intelligence in Medicine. And he's also the founder of the Medical Intelligence Society, which is getting launched as we speak. I don't think I can say enough words about Dr. Anthony Chang, so I'm going to limit it to this. What I can say for sure are something that are very personal to me. When I was starting my journey, trying to discover what or understand what is machine learning and what are its implications in healthcare, I just saw one name. I saw the name of Dr. Anthony Chang. That's all I could see. And it's been a great period of mentorship and support over the last few years, engaging with AI Med and learning through all the wonderful meetings that he has fostered and he has led across the world, not just in the US, but across the world. He is a world-renowned leader. Unlike many other clinicians, he is actually trained in various aspects of machine learning. He has numerous publications. He has been leading numerous organizations in this front. So anytime I can think of one name, which essentially is symbolic of AI in healthcare, I think of Dr. Anthony Chang, a great friend, a great mentor, very well respected throughout the community. And similarly, AI Med is a world's leading organization, bringing all aspects of machine learning or AI in healthcare together, all people from different age groups, from different backgrounds together. And we are very excited to have him here to talk to us today. And this picture is from last year. And this is very, very symbolic. You know, AI Med and BrainX Community have common values. We are in it for just one purpose. We want to help everyone. And I think this is very symbolic of what we are trying to achieve over here. There's Dr. Pepe, there's Dr. Chang, and myself in between, proud to be surrounded by the brightest and the smartest. So with that, I'm going to give it to Dr. Chang. And as I do that, I'm going to ask him for the Drivers Unplugged section that how did your journey start? What led you to this? And what inspires you to lead us into AI in healthcare?
Well, thank you, Piyush, for the accolades. And I have to say, you've been such a staunch supporter and friend and colleague throughout this whole process. It just makes a journey like this much more fun. So, well, I was classified as probably the ultra nerd when I was in high school. I think I just checked my yearbook because I want to make sure this statement's correct. I think I'm literally the only high school student in my high school that was in the chess club, math club, and the computer club. So I've always loved numbers and taught statistics ever since I was in college and dreamed about having a supercomputer, doing what we're doing these days back in the 80s when I was a fellow in training, and learned about chaos theory from my mentor and surgeon and friend, Dr. Bill Norwood, who I'm sure all the cardiologists know, and just always had a fascination with math. And the more complex the math, the more I enjoyed it. So, and then 11 years ago, when the IBM supercomputer Watson beat the human contestants, I downloaded the application for the Stanford program and was fortunate enough to get in. And that's sort of like the last leg of my journey. And then, of course, meeting great friends and colleagues like you just makes the whole community much more fun. Sort of like your nerdy doctors club, basically, right? But affecting outcome of patients, which is really, really key, as you said. So.
No, thank you.
All right.
That's
Okay.
yeah, that's great. And we'll go ahead with your presentation. By the way, for a frame of reference, 1980, probably some of us were still in diapers while you were figuring this out.
Yeah. So that's exactly right. That's how old I am. So I just thought it would be fun, since this is a very sort of a educated and already focused group. I thought I'd just poke a little fun at some of the misconceptions rather than give you a talk on AI in medicine, because you're probably very familiar with it. So this is literally words I took out of conversations and webinars and things like that. So one comment was, AI is good for COVID-19. I mean, why would it not be, right? So I just want to remind everyone that I have a public health background, and I actually think that even for 2020, basic public health is probably still the most important thing when it comes to a huge challenge like a pandemic. And we didn't do public health very well in this country, or other countries for that matter. And so I think we need to think about, in addition to AI, what basic tenets of medicine should we also be sensitive to and also implement. So I think the containment strategy was what we needed. The bottom line is, if we did containment really well, we wouldn't even need AI, because there would be no pandemic. Now, the second lesson, I think, when we looked at predictive modeling, and you notice that the range of predicted deaths for any region has been pretty wide, right? I mean, in the media, you hear, well, we might lose 50,000 Americans, to some people say, well, we might lose 2.5 million. Well, it's like a random number generator, right? Who's going to be right and what's going to be accurate? And I think part of the problem that we've had in terms of really being accurate in terms of predicting is not fully appreciating that a pandemic prediction in terms of number of deaths is a very complex mathematical problem. It's not a complicated mathematical problem. And I think we need to do a lot better in terms of getting feedback, sort of real-time feedback, to better predict the number of deaths. But hopefully we learned a lot. Now, where AI is going to be very impactful, I think, for treatment of the disease is working with AI for drug discovery. So this is, some of you may recognize this. This is the AlphaGo and DeepMind work on predicting protein folding, quaternary structure. As you may or may not know, those of you who are familiar with molecular biology, it takes weeks and months to come up with this, but they're able to do it based on an AI algorithm. So in summary, I think to think that AI alone can fix the problem of a pandemic is, I think, overly simplistic. And I would just say, to go to war with viruses, I think public health strategy is kind of like having armor. It's basic. And then if you want to add AI and innovation, it's kind of like having some weapons. So you kind of need both to fight a war with viruses. So I just wanted to give some recognition to the problem that we have. The second comment I've heard is AI really a good fit for COVID-19 in terms of predicting outcome? And I think, again, I'm just going to go over why I think it hasn't worked as well as we hoped. This is, for those of you who are familiar with the whole genre of complexity theory, this is what's called a Stacy matrix. So Stacy matrix basically plots technology and requirements, clear, unclear, or known and unknown. And in the upper right corner is chaos. And in the bottom left corner is simplicity. So in the middle is where complicated and complex live. And I think with a pandemic, you clearly are in the complex realm and maybe even going towards chaotic. And my hope is that AI in the future will be able to drag a complex problem into at least a complicated area so you can simplify the problem. But right now, without AI in full support of various aspects of the pandemic, I think we're going to be in the complex, chaotic sort of border. And then this is, some of you may not have heard of this, it's called the Kinefin framework. And it is a very elegant way to look at, again, what's obvious, what's chaotic, and then what's complicated and what's complex. So in a complex situation like we're in with the pandemic, as I mentioned, you're kind of just probing, sensing, and responding as opposed to figuring it out and analyzing. So when we talk about a complicated situation, and I'll have a few more slides just to elucidate more on this concept, it's very well geared for engineering solutions. But once you reach the biomedical domain of complex issues, then you have limited return and just have to have realistic expectations. Again, this is complex versus complicated. So complex is on the left, complicated is on the right. So on the right, you can deconstruct a car into hundreds of parts. And so one of the questions I got recently asked in a webinar was, why is it that we can send SpaceX, to the International Space Station and it had that booster rocket come back to Earth within 10 meters of where it left the planet, and we can't figure out the pandemic? And my simple answer is, well, even though that's very impressive that SpaceX can do what it did, it still is a complicated problem, difficult, but solvable, predictable problem, ultimately. And the problem with biomedicine, and especially in case with pandemic, we have to deal with different governments having different regulations and different people behaving differently, especially like in Southern California, then it becomes a complex problem, which is not easily solved with traditional engineering solutions. Although those of you who are really well-versed in engineering and data science know that there is something called control theory, which is in essence building a feedback loop for a complex problem by using engineering solutions. So there is hope that we can get better at predictions, but we do need a control theory solution to the pandemic. All right, enough about COVID-19. I think we're fatigued about COVID-19. So let's talk about a few other misconceptions. And I took a few of my favorite ones and then added a few new ones. So this is one of my pet peeves, that when someone says, well, it's just like a black box. Well, okay, I'll give you that there's a lot not understood about AI, but people are trying. There's something called LIME, L-I-M-E. I don't know if that's a topic that's been discussed at BrainX, but essentially is a way to make algorithms a little bit more understandable, interpretable, and less of a black box. But if I were a machine, I would complain about the human pink bag. There's a lot about how a brain thinks that is not necessarily easily explainable. And, you hear about phrases like, oh, my gut feeling or my visceral reaction. Well, how do you describe that in words and mathematical expressions? So I think if I were a machine, I would complain about the humans also, in that they have these mysterious pink bags that doesn't necessarily always have an explainable situation. So I think one of the problems is that we sometimes are a little bit confused about explainability versus interpretability. So explainability, which is what everyone talks about in terms of AI, and also the more sophisticated the learning technique, the less explainable it is. And that's unfortunately just the nature of AI methodologies. But I'm a cardiologist and I deal with patients with pacemakers all the time. And I have to say the explainability level for me is very low because it's a lot of engineering aspects of the pacemaker. But what I go with is trusting the machine, the equipment, and I have interpretability. I can program the computer, the pacemaker, I can put settings on it, I can interrogate the pacemaker. So I'm functionally very trusting of the machine, and it's because the interpretability is very high, not necessarily explainability. So I think most clinicians can live with high interpretability and don't always have to have high explainability. But again, it takes some clinicians to really understand the nuances of machine and deep learning. So I'm glad that BrainX is helping with that. This is a complaint I get from a lot of my colleagues. AI isn't possible to learn. And yes, when you look at the map of mathematical sciences and AI, it is quite a conundrum in a lot of different areas. I think I've taken courses in literally all of those areas while I was in school. So it is very, very difficult when you look at AI as a subspecialty. And it's getting more complicated all the time. So that's the not so good news. But I do think everyone can understand data. And if you're a clinician and you're just decided that you're not going to go to school or get training in machine learning and deep learning, but I think every clinician can start to review and understand more the essence of data in terms of the database structures and how data can be managed, and so that we have much better data to work with as we go up the pyramid of information knowledge and AI and then wisdom. So the wisdom I left as a circle because that's a very human aspect that perhaps machines are not ready to do yet. So you can always help out. And just those of you who know me knows I'm always drawing space travel analogies. There are a lot of engineers on the ground that didn't go to the moon. And it took, something like a couple of 100,000 employees from NASA to launch Apollo 11 to go to the moon. So everyone can definitely be an important contributor to this game. The other thing about learning machine learning, either in any format, is that you need to leave your comfort zone. So by leaving your comfort zone, I think it's directly proportional to the dividend you're going to gain the farther you go out of your comfort zone. And I have to say, when I was at Stanford, I definitely felt like I was in the growth zone. I mean, there were people a third my age, much smarter than I was with the programming part, and very humbling to know that just because you're oldest, you're not the wisest. But I mean, I'm going to give you a quick example of one of my favorite mentors, Dr. Richard Van Praagh, who is now 92 years old. And when I had dinner with him that's pictured here in Boston about a year ago, he was still showing me a mathematical formula that he thinks will explain or set forth a new theory for congenital heart disease. And he was so excited to share it with me. And I was excited to share with him what I've learned. So that sort of spontaneous curiosity, even in a 92-year-old, is just fascinating for me. And I think he's always traveling in the growth zone and is never in a comfort zone. So travel outside of your comfort zone. And also at some point, I think we need more and more people who are both clinician and data scientists, because I think it adds a different dimension to the whole field. And as an example, this is Formula One racing, one of my hobbies. In the history of Formula One racing, there was actually one American driver, Jim Hill, who was both a driver as well as an engineer, and from, I think, Caltech. So by having that dual background, he was able to figure out while he was driving, he was probably thinking while he was driving, that when he turned a corner, the drag on the car was a little too much, but if you could distribute the drag, like with the rear wing that you see in the car, that's his invention. So by having that dual perspective, I think it does help sometimes to isolate and better define exactly and precisely the problem you need to solve. And again, that's something we see, right? A lot of times, both the AI and the medical sectors are very well intentioned, but perhaps even together may not solve the most important questions and problems. AI will replace us, right? So no longer are we talking about AI replacing radiologists. I actually predicted 5 years ago in the public debate that there will be more radiologists in the future, not less, because I think AI is going to make that profession even more interesting and fun to do. So we'll see what happens in terms of the number of radiologists. Now remember, or some of you may remember, when the ATMs came out, everyone thought that there goes the sort of branch banking concept, that the banks will be closing and the tellers will be out of jobs. In fact, more and more people started working in banks. And the reason is because they just simply reconfigure their jobs. No longer do they have to dispense money. They just went into financing areas. And actually, there were more branches of banks after the ATM has come about than before. So I think AI is going to have that same effect in medicine, that the more we have, the more people we're going to need that understand it and know how to deploy it. So I'm not the least bit concerned about clinicians losing their jobs. The other thing about the aspect of misunderstanding that AI will replace humans is that, and this is thanks to Gary Marcus, a friend and AI guru, who said, can you just explain to me what doctors do? so I said, well, let me think about that. Let me get back to you. So on a Saturday, I plotted out what people do. And so I'm a cardiologist. So if you divided the brain into three big functional areas when it comes to clinical medicine, there's perception, which is like medical image interpretation, analytics, basic analytics. There's operation, which is manual procedures, using your hands and your eyes, obviously, and cognition. So cognition is more complex decision-making, creative problem-solving, things that computers are not very good at. So if you have an understanding of your job, and like I'm a cardiologist, so I'm just going to plot out cardiology. We are heavily like 60-40. If you don't count operation, just to make it a little bit simpler, you're about 60-40 in terms of perception versus cognition. The radiologist would be even more on the perception. So if you have a full understanding of what you do, then you can both, I think, incorporate or accommodate computers more in your line of work, the perception part, and then perhaps inspire people or your data scientist colleagues to do more on the cognition side, or just redistribute your job so you're never out of a job, essentially. So the joke is, and maybe not so much a joke now, is that doctors that understand AI will replace doctors that don't. And I think I used to kind of chuckle at that because I didn't think it was that true, but I think you're starting to see patterns in certain subspecialties where that remark may have some relevance. So AI is mostly hype. We know that we're sort of at the peak of inflated expectations, but that's true for any technology. I do think that we're about here, which is that the hype is still exceeding capability. But I think in 5 years, 5 to 10 years, we'll start to see how the hype is actually matching the capability of AI. But I think we do need to be patient. So this is a slide I was showing last night at a meeting. It's called Amara's Law, and Bill Gates have said the same thing, that we tend to overestimate technology, especially AI, I think, and then underestimate what it can do like 10 years from now. So I do think that we're about here. So we're still overestimating it. And people are actually a little bit fatigued about the hype of AI. So we have to be careful, because the next 3 to 5 years, I think, is our most vulnerable time in terms of people losing interest. And I'm talking about your naysayers, the not so diehard advocates are going to start losing interest unless they see some real evidence that it's making impact. So I do think we have to work hard on that. And the reason we need to be patient is because at the end, the dividend is absolutely big. And I think it's going to be even more than we predict now. Another misconception is, deep learning is the end all be all. It's kind of like the final stage of AI. And I actually think, I love machine and deep learning, as you know, but I do think that clinicians need to get back into the game of AI in medicine and healthcare, because I think we're going to reach a third wave, which is cognitive architectures. And this is Bill Voss's work. And I think he's absolutely right. We need to start figuring out what are relationships between objects, and not just be able to interpret what the object is, but what are the relationships? And I think an example of this making impact is something called recursive cortical network, RCN. And it's a special kind of deep learning that will start to relate dimensions in space and how objects relate to each other, so that you can do cool things like predict what the image looks like without actually visualizing the image. So you can actually go around an image and figure it out. So this had impact with CAPTCHA, which is, as you know, that thing that you fill out when to prove that you're human. So they were able to figure that out finally. Another, I think, misconception is that deep learning is going to be more superior to humans. Well, that's partly true, but let's think about swarm intelligence, which is proving to be the most effective way of predicting outcome. And I think we underutilize swarm intelligence, our swarm human intelligence, I should say, to help machine and deep learning even more. So it turned out that I think Matt Lundgren, who I just talked to today, published a paper on the concept of swarm human intelligence plus deep learning was the most superior methodology for support. So I was at the, when I was able to travel with my girls, we went to the Monterey Bay Aquarium, and I thought this was really funny because I feel like we are functioning on the left, isolated centers of AI in healthcare, not a whole lot of interaction. And we should be on the right, where thousands of fish kind of swim together and make impact. There's a little bit of collaboration on the left there, but not much. So I think BrainX and AIMed are really instrumental in pulling everyone together. So talking about clinician AI collaboration, this is like the ultimate collaboration. My friend Leo Telly was kind enough to invite me to help be on the faculty of a meeting in Beijing 2.5 years ago, back when we can all freely travel. It seems like a fantasy now. But 100 clinicians with little or no AI machine learning background paired up with 100 data scientists from the local university in Beijing and solved queries and research problems using the Mimic3 database over a weekend and presented abstracts based on their collaboration. So the visual I remember from that meeting that I'll never forget was a very senior Department of Medicine chair in his 60s working side by side. I wish I had taken a picture with a 20-some-year-old, woman data scientist and actually having very friendly chatter back and forth about what they're finding on the project. So I think that's what it's going to be like in the future. Either train yourself to be good at this or pair up with somebody so that we practice medicine differently. So I think medicine's becoming a data science, not a biological science that is supported by clinicians. So this was an interesting picture of so we talk about transitions here. I guess the designer of this bathroom couldn't decide to put a modern device, which is kind of like symbolic of AI, and a more traditional device. So I call this status quo. And I think I mentioned this, and Payush, you may have heard me. Without worrying people, I kind of stood in the corner of the bathroom and just see what people did as a behavioral test. And I just wanted to count 10 people and what they did at this when they came up against this decision. 9 out of 10 people used the paper towel. And then the 10th person was interesting. He actually dried his hands with a modern device, but he still pulled the paper towel out of the dispenser. So it's like he didn't quite trust it or something. So I just thought it was interesting, human psychology. So speaking of transition, I think we're at best now in a symbiotic stage, right? Because the clinicians and data scientists kind of hang out sometimes and do projects, but I think we need to go farther. I think we need to be at the synergy stage where 1 + 1 is 11. Eventually, what I like to see is what I call the convolution stage, which is most of us will be educated enough on AI that we actually have a third way of thinking about medicine. So the convolution is a third function from 2 functions. So you actually think very differently as a clinician because you have an embedded education and knowledge about AI, but I'm talking like a decade or 2 from now. So we need access to healthcare data. That's all we need, right? Because we talk about precision medicine and population health. So I think the misconception is if we can just get our hands on data, everything is solved. Well, do we know how messy data is in healthcare? Yes, we do. So data is not the only solution, but you need to get smarter about the data. So one of the projects I'm interested in doing at some point is trying to come up with a hypergraph structured learning, but you need hypergraph databases. So Match.com and LinkedIn are all in a graph database. But medicine is still in a relational database, which I think is going to be very, very limiting in the future when you go beyond medical image interpretation and very simple EHR projects. We absolutely, at some point, as a domain need to convert to a hypergraph data format. And just to talk about future of medicine and AI a little bit, I think a lot of things will be pushed out to the periphery. So a misconception might be, well, AI is going to be all in the cloud, but I think also we're going to start seeing embedded type AI, and just simple AI in your wearable technology is going to be, I think, coming this decade as well. So cloud AI is going to be also supported by embedded AI locally. All right, so I know you don't see much water in Cleveland, but don't be left off the ark. And I think, people talk about AI in medicine's exponential improvement, but I actually think it's not going to be exponential. I think it's going to be between linear, and I talk about this a lot, which is let's try to achieve intelligence-based medicine. But I think we're not going to get there in one fell swoop. I think it's going to be like a jagged edge here. We're going to have some exponential looking improvement and progress, and then we're going to kind of fatigue and then we'll come back again. And then, so this is the progress. I think that's the progress I'm going to expect to see. So yeah, so it's going to be this intermittent explosion, mini explosion in interest and breakthrough. And then we will get to exponential, but not all in a decade. So again, let's focus on intelligence-based medicine rather than evidence-based medicine. So these are words I think ring true from Winston Churchill, that when we talk about pandemic or when we talk about AI medicine, now this is not the end. It is not even the beginning of the end, but it is perhaps the end of the beginning. So I think we're in the end of the beginning for both the pandemic as well as AI medicine, and we'll just have to keep going. It's a journey for all of us. And what I would like to see on a personal note, I have 2 daughters with very complex medical conditions. I would just love to leave a platform for practicing medicine that will be good for them the rest of their lives. So that's part of my personal passion and interest. So as Payush has said earlier, he's helping me form the Medical Intelligence Society, MIS. So it is basically mainly clinicians with a passion for AI, but it's also open to everybody. It is close to commercial organizations and vendors. So it's mainly a very honest, down-to-earth discussion on projects and what people liked and didn't like. And I invite you this year. It's going to be a virtual meeting, so I'm going to miss all of you at this annual meeting. We typically have about 100 or more people. So this year it'll be virtual, July 31st to August 1st. And Payush is helping me put together an amazing program. We have some really great keynote speakers that will talk about the prevailing issues of today and how it relates to AI medicine. I think one is going to be on COVID-19. Leo Chelly just accepted the invitation for August 1st. And I think we'll have someone talk about racism and how do we use AI in medicine to perhaps mitigate the racism issue and inequity. Also, as I mentioned briefly, I'm privileged to be the Dean of the new American Board of AI Medicine. And that's going to hopefully democratize knowledge and then provide certification and eventually board certification opportunities for clinicians as well. So 3 to 5 years from now, I think we will be mature enough for a board certification like you've seen for informatics right now. So spent a lot of time, put together a array of resources. There's the ebook that you can download for free. And the ebook is now matured into a textbook that will be out, I was just told, in the next 10 to 20 days. And it's a textbook written for both the clinician as well as the data scientist. For the clinician, half the book is on the basic aspects of data science. And the other half of the book is for the data scientist, which talks about how each subspecialty can use AI in the practice and what's to come in the future. We also have launched the Intelligence-Based Medicine Journal. Payush seems to be involved in every project that I have in a good way. So we have a lot of reviewers and board of editorial board. I have to say I'm pleasantly surprised at the pace of contributors, we're now averaging about a journal article a day, which is pretty early for a journal in the first year. So we have our inaugural issue coming out this early fall, and the whole issue is going to be dedicated to COVID-19. And then there are a lot of talks that are loaded on the website as well. And our big meeting, annual meeting, is in December. Unfortunately, we will probably be virtualizing this meeting, other than I'd love to meet all of you and personally. And I think that's how I met Payush. But this year we're going to be virtual. December 9th to the 12th are still the dates. And we usually have 1 or 2 mini satellite meetings. And this year we're going to focus on 2 topics. One is global health with due respect to the pandemic problem. And also we're going to have a session on extended reality and how you apply AI to extended reality in medicine and healthcare. I want to thank my donor, who is the granddaughter of Walt Disney, who believed in the vision of AI in healthcare and medicine, and my very good friends and colleagues from the Stanford School of Medicine AI program. And that's my contact information, including my cell phone under mobile. Feel free to contact me if you need anything. If you need any information about the MIS meeting, Payush is helping me this year, so you can contact him as well. So with that, thank you very much, Payush, for the opportunity, and thank you, BrainX.
Thank you, Dr. Chang. That's always exciting to listen to you. And one of the comments I was making to Dr. Chang yesterday, we were having a discussion about the Medical Intelligence Society meeting, was that although he might have presented some of these things at multiple meetings, and I might have seen those slides, it's always so much refreshing. It's always great to listen to him. And he always puts.
Well, I know you're listening, so I know you're listening, so I had to change it up just for you.
Yeah, no, I think they are very, very informative, and the context is very helpful. And I think I'm going to take some of these questions that people posted over here. The first one is with regards to that meeting that you mentioned in China. It's in context with something like that, or other datacons that we have had. So Ashish Khanna wants to know, do you have the data on academic output from datacons like the one in China, and how many ideas have been developed at these meetings to impactful
Great question. First of all, I think Leo is very good about actually publishing and encouraging people to publish from Datathon. So you're absolutely correct. If we just do the Datathon, I think it's a great dividend just doing the Datathon, but to get an academic publication is even better. And hundreds of papers have come out of his Mimic 3 and 2 and 1 databases and papers, and which are always very valuable insights because someone asked a very good question. So it's almost like you have a magic box, and we don't want to say the black box, but a magic box. You can ask a question and the data in there can just give you the answer. But having said that, I wanted to personally explore the possibility of what I call agile clinical science. So I actually challenged my data science team to turn in an abstract within 1 hour using the Mimic 3 database to a meeting that had abstracts due that day. So the challenge was 1 hour. They had to go into the database, do the project. I was helping them write the abstract, and we did it in less than an hour. We turned in an abstract that got accepted. So it just goes to show you that you don't need weeks and months and maybe even years with Excel spreadsheets doing research on the database. You just need a good database, and you need some smart ways of looking at the data, and that's all you need. And hopefully that will change the way we look at research forever. Is no one should be doing analytics off of Excel spreadsheets any longer, because it's all very R and Python driven these days. So for speed, if anything, so.
Yeah, no,
okay, you do have a big lake in Cleveland, so I apologize. I like that comment. Thank you. Doug, thank you. You can have the lake. I'll settle for the ocean.
So Anthony,
Thank you.
let me put it in context. Let me put it in context. So we talk about big data. So Doug Mail is an engineer, and we
Yeah.
talk about big data in healthcare. I think the context is the same. In healthcare, it's actually small lakes rather than
Yeah.
big data. Whereas when you talk about Google or other things, that's what they call real water over there. So I think it's contextually very true. Good one, Doug.
Yeah, but I do make a point. If we're going to relate to the lake analogy, I think I sometimes consult in hospitals, and they ask me, "How should we have? What's our data strategy? What should it be?" I say, "Whatever works for your team." Because the question is usually, should it be a data lake, which is more sort of nimble to work with, or should it be a data warehouse, right, where it's more structured? And I said, well, traditionally, business intelligence likes data warehouses because it's just easier to visualize the data and everything. And data scientists like the data lake because there's more fluidity. And I said, actually, it's probably good to have the best of both worlds. And so I kind of coined it a data reservoir because it's partly man-made and partly not. And then, of course, I realized that was a term already used by people. So, but I think data reservoir is a good approach. You want some structure, but enough fluidity that you can do really cool projects in biomedicine.
That's great. So Dr. Kare actually joins us from Middle East and from UAE, and he has a question: is COVID-19 good for AI? Well, I don't know if COVID-19 is good for anything, but
well, those of you who actually read the newsletter I put out in AI medicine, I had fun with this concept. What makes these viruses so smart and so good at killing people? So I said, I think they're a complex adaptive system, right? If you think about complexity theory and a complex adaptive system, all the subunits work really well together, and there's like a group intelligence, and they do one thing, right? One singular goal, just kill off human beings, right? And replicate and kill human beings. And they do it incredibly well. And it's almost like they have a collective intelligence, which is kind of scary. And the reason why they're still killing off people in the summer right now is I think it's mutated, or we haven't proved it yet, but I think it might have mutated. And it's almost like they kind of know collectively without a central leader, which is really important. So in a complex adaptive system, it's just like complex theory. You're not allowed to have a central leader, but the group, just like ants and just like, birds, they function really well as a group. They don't need a leader. And perhaps humans can learn from this. I commented that in the newsletter. Maybe we just need to function better as team players and not be so, sort of misled or just confused by leadership. Maybe we should just try to find a way to function as a group, everyone do their share, which is what viruses do. I mean, viruses are thriving because we're not doing that, So yes, COVID-19 is good for AI because AI will hopefully learn as we are now, right? The predictive models are not working really well, and we just have to find a way to do better. And I think it's going to make AI better, and it's going to make people appreciate AI and what it can do. Humans are overwhelmed, which is what we're seeing also. Great question, though. I like that question.
Well, a couple of questions related to ABAIM board. You got everybody excited about that, looks like here.
Yeah.
So one is about, will it clash with other boards, or how does it differentiate probably from other boards?
Okay. Yeah, actually, Ted Shortlift and I are very good friends and colleagues. And he and I both feel that the ABIM board certification, which by the way, won't happen for about 5 years. We're just going to certify, it's like a certification for people that are interested, and it will mature into a board certification in 5 years. And I think it will be very complementary to the informatics board certification. I myself will probably do, I'm going to take the board, the informatics board probably this year or next year, because I want to be, sort of knowledgeable in both areas. I think you'll see probably 10 or 20% of people that will probably go for both. And just like cardiology and intensive care, which is what I do, not many people are double boarded, and not many people need to be double boarded. But I think 10% will probably try to be double boarded. But I think this board certification will be very, very much in synergy with the other one, just to raise awareness for both informatics, and intelligence. So I call it the two important I's in our practice is informatics and intelligence. And by the way, Ted, who is the founder of AMIA, is fully supportive of this concept that we try to be very, very synergistic together. Let's see the other question.
Related question about it being available to international graduates.
Yes, we definitely would like to see which countries would be interested. We definitely have international members on the advisory board already with the intent that this will be international. So absolutely, we would really, really like to see international people, and not just clinicians, by the way. This certification we like to see for hospital administrators and residents in training, medical school students, nurses. So we like the reason why we didn't go to board certification right out of the gate is because we actually want everyone to have access to this. And then we'll segment to the clinicians to get board certification.
That's great. So let me ask you a question related to education in AI. And I see like one of the medical students is also here on this group. And like to a lot of people, it's very scary. You know, these neural networks, these complicated mathematical formulas and everything, they're very scary. And honestly, a lot of us have been very far away from that kind of mathematics. So what would you say to a lot of clinicians who want to understand AI better and they want to collaborate with others? What is the basic minimum understanding that they should have, and how should they approach it? Other than like, you know, your wonderful resources that AI made in your book, I think those are some great starts. But some words of wisdom around them.
Yeah, I think it's a very personal journey, and you should take it however far you want to go. Yeah, when I look at the ocean out here, I'm scared to go surfing, but I started like, you know, just doing body surfing for a little bit, and you just kind of warm up. And I think that's with AI too. You can just start with looking at a couple of courses online just to see what it's like. I have to warn you though, some of the courses like with Andrew Ng goes right into the hardcore math and doesn't give you much warm up. But there are many short video clips now that actually are quite good. I listed all of them in the book, and I'm constantly adding video clips. So for those of you who see an outstanding video clip, please email me. I have a list accumulating of great videos. And I'm actually putting together a 25 segment video series. I'm about to do the first segment actually. So because I kind of, having the hat of the clinician and hat of the data scientist, I think I can figure out what the clinician really needs to understand. And the book is essentially was a distillation of all of my Stanford class notes. You know, just like, okay, what does a clinician really have to understand to make inroads into this area? And it's not everything, obviously. You know, there are lots of stuff that you'll never use. So I kind of distilled it into sort of hardcore concepts that I think will be very important to understand. And a lot of vocabulary stage you'll run into it. So I think it's my best advice probably is to just jump in and have fun. If you're not having fun, then it's probably not for you. But you just have fun and with in mind that this is going to make a difference in your career, that you have some understanding of this, particularly for my younger colleagues.
That's great. What about the converse? Because sometimes I find that the data scientists or the machine learning engineers like have a hard time.
Doug, we need to keep you around. You ask very good questions. There is a medical school, I'm happy to say, that's going to combine a medical degree with an engineering or data science degree. So when I presented at the Council of Deans at the AAMC last year, that was actually one of the questions. And I said, you know, I think it's actually going to help us to be more human, not less human. And because if you think about the typical doctor's visit, right now, the doc is typing away on the computer. That's not very human to me in terms of the interaction. And I'm hoping that AI tools will actually free us up to be more human, and we all want to be more human, maybe with a few exceptions. We all want to be more human with our patients. So, and that school actually insists on these students, dually educated students, to take a curriculum of liberal arts courses to balance, you know, the machine or the computer part of their education. So I think there's a chance that AI can actually help focus on important things that we don't do a good job of. I have to say, humans not very good at mitigating bias or mitigating racism. And I think those are things that can be a little bit more automated to bring about more equity in medicine. So yeah, I totally agree. If there is overemphasis on the machine part, then you will forget, you know, how to cook. So totally agree.
That's great. I think, again, a buildup of excitement, wanting to know about how to join the MIS meeting. Of course, I'll share it through the BrainX community platforms everywhere, so that we can do that. And I'm sure it will be a great success.
Yeah, we have, you know, I found out as I was preparing a talk on the overview effect, and for those of you who have not heard of it, it was very inspiring for me to keep going when I was at Stanford and having difficulties. It's like the gist of the overview effect, if you haven't heard of it, is that you have to be a space traveler to appreciate your home, the planet Earth. And the farther you go, the more profound that experience is. So that's the gist of the overview effect. There are about 5 videos on the overview effect. They're all worth watching. And when I was having a difficult time, I said, okay, I want to go farther into space. I don't want to just settle on the International Space Station. I want to go to the moon, right? And now, of course, we're thinking about going to Mars. So I want to go as far as I can. So I kept going. And every time I got discouraged with the homework assignment that looked impossible, I would play that overview effect video to inspire myself to keep going. So I think the farther you go in your education, the more profound is going to be your contribution as well as your experience looking at medicine. So I totally suggest you go as far as you can.
Well, that's great. I think we had a great session with you, Dr. Chang. Thank you so much for making it so special for the entire community over here and joining us. And
Thank you so much.
I always think about, you know, if you need an answer to a question, we Google it. If we need a leader for AI in healthcare, there is one name, Dr. Anthony Chang. That sums it up.
Can't do it without really, really amazing people like you. You'd just be a lone champion and not a community. So you're great at contributing. So
great. With that, I think we'll come to an end. Thank you everyone for joining us, and see you next time. The video will be posted on the YouTube channel for BrainX Community soon. Take care.
Thank you. Bye, everybody. Enjoy your lake.